Question 1. Use the information diagram in proof to fill in the blanks. Given that M is parallel to N, prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Alright, here's the example, the proof, and it says match each letter in the right column with the correct phrase in the right column. So I'm noticing that B is used 4 times, A is used once, and C is used once. Before I jump into looking through this as using context clues, I'm going to first duplicate the tab and see if there's an example in the level up section that we can use as something similar. So I'm just going to scan through until we have a proof. So this one just shows a triangle as shown in the diagram, and then prove that measure of angle 1, 2, and 3 equals 180 degrees. Well, this is similar to what we want to prove. What's different is that we have M as parallel to N. We're still trying to prove that the inside angles of this triangle equal 180 degrees. And if you notice right here, we have that BC is marked parallel to YZ. So we actually have the same setup. They just wrote it differently given that the triangle was ABC. So we still have the same information. This will be a great use for an example. So I first noticed what we were proving, saw that it was the same as what we're proving in this question 1, and then I looked at what we were given, which was parallel lines, and I looked in this diagram and noticed that YZ is marked with these 2 chevron marks to BC, which indicates that they're parallel. So we have the same information. And then this is what I would do. I would first notice that it had measure of angle ABE plus measure of angle 4 is equal to 180 degrees. And I would see if there was anything set up similar to that in this. And I'm noticing that there's not, and that's okay. I'm first going to notice that ABE, then I'm going to notice that ABE right here makes up angles 1 and 5, and that angle 4 is this angle right here. And now, since I didn't see kind of like a direct correlation in our example proof, I'm going to use context clues. So the statement before says that these 2 angles, ABE and angle 4, are linear pair. Then they said the linear pair definition of linear pair. Well, there is a linear pair postulate that states that, or theorem, that if you have 2 angles that are a linear pair, then they add up to 180 degrees. I'm not sure if that is available in the key terms right here. So there's the linear pair, there's not the linear pair postulate. However, the good context clue is that they use the definition of linear pair, and then you would use the theorem. So linear or postulate. Linear pair postulate. Right there. So definition, theorem, or postulate. So now, jumping back to our example proof to see, we have angle 2 and angle 4. So these ones are diagram specific. And I'm going to check to see they're not in the same place in this diagram as they are in this diagram. So again, we're going to jump to context clues. We're just going to notice that angle 2 is created right here by this. I'm not sure why my mouse is glitching. So we have this transversal right here, and we have the parallel line right here, and the parallel line above it for line M. right here. And here's angle 4, and here's angle 2. So this goes back to what kind of angles you have. You have two angles that are on a transversal. So are they on the same side of the transversal or different? So here's the left and the right hand side of that transversal. So notice that angle 4 is on the left hand side and angle 2 is on the right hand side, so they're alternate. Now, are they between the parallel lines? Yes, they are, so they're alternate interior angles. So that is what B is, alternate interior, not exterior. So alternate interior angles. And so that's what angle 2 and 4 are. And notice that angle 3 and 5 have the same similar setup, just on a different transversal. There's the transversal, and here's our parallel lines. Here's the angle, and here's the angle. So again, it's the same setup, just using a different transversal. So then, if we follow here, we have that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, and this has a blank there. If I'm going to continue using context clues and I look up here at statement 5, I notice that we have this same setup right there. I notice that measure of angle 1 lines up. Measure of angle 5 is now measure of angle 2, and measure of angle 4 is measure of angle 3. So I'm going to look and see if there's any other statements that can link these. And I notice that the statement above says measure of angle 2 is now is equal to the measure of angle 4. So they actually just did measure of angle 4 is now the measure of angle 2, since they're equal to each other. And here they have the measure of angle 3 is equal to the measure of angle 5. So instead of writing measure of angle 5, they wrote the measure of angle 3. So that's using substitution, and I'm not sure why they wrote it in a different order. Maybe because they just wanted it to go 1, 2, 3. Either way, that's okay. So this is the substitution property because they replaced 5 with 3, the measure of angle 3, and they replaced the measure of angle 4 with the measure of angle 2. So that's our substitution property. That's how I'd go through answering this question.